In this section, we'll be looking at our very last transformation. This transformation is called a horizontal stretch or compression. Let's go ahead and look at a picture that shows us what a horizontal stretch looks like. Again, we have our XY plane. And let this red graph be called f of x. What we want to go ahead and do is we want to stretch this graph horizontally. This is done by the following green graph. Again, what we did algebraically was we changed the x values, but we didn't change the y values. The key difference between our horizontal stretch and compression is that we didn't change our x values uniformly. So for example, from here to here, maybe the distance is, let's say, 3, but maybe the distance between here and here is 12. So to change our x values non-uniformly, instead of adding by some number, we're going to multiply by a number. Let's go ahead and rewrite this geometric piece of information using algebra. All right. Given f of x, and also given this g of x, which is going to be equal to f composed with b of x, then we can either horizontally stretch or compress our graph as follows. If b is greater than 1, then our function g of x is a compression of f by 1 over b units. If our b value is between 0 and 1, then g of x is going to be a stretch of f by 1 over b units. I've forgotten one word for each of these, so this should be a horizontal compression, and this one should be a horizontal stretch. All right, so we want to go ahead and sketch the following equation. Let's start off with what we're given. Y is equal to 1 over 4 x raised to the third plus 1. Here, we see that this graph, y is equal to 1 over 4 x raised to the third plus 1, is going to be the same graph given by 1 over 4 x raised to the third that's been shifted up by 1 unit. So now, this second graph here that we just obtained is going to be the same thing as y is equal to x raised to the third with a horizontal shift by 1 over 4 units. So we can go ahead and draw these graphs sequentially. Our graph number 1, we just have y is equal to x cubed. This graph is pretty familiar and looks something like this. In equation number 2, we're multiplying our x value by a 1 divided by 4, and this is going to be either a horizontal stretch or a horizontal compression. And since 1 over 4 is between 0 and 1, we know that this is going to be a horizontal stretch. So for number 2, our graph should look something like this. Then finally in number 3, we know we're shifting all the y values up by 1 unit. This is going to be a vertical shift, which means our final graph should look something like this. Okay, and that's it.